Ferguson. I'm from Memphis. I work for a company out in New York called Vector Media Group. Historically, I've always kind of worked for agency and small agencies, and I've always kind of been the server person or the server dude, the one who was tasked with actually liking doing server stuff. And that kind of led me into doing a lot of DevOps type stuff. And I kind of pulled this talk out of one of my other talks where I went into this tangent on continuous integration and how to set it up and how to utilize it to test your code automatically. So I kind of pulled this out of one of my other talks, and this is the first time I'm giving it. So I hope you guys, or everyone enjoys it. The first thing is to figure out what is continuous integration and continuous deployment. So the first thing about continuous integration is it's the process of frequently integrating code changes into your existing code repository. It's merging branches to master or production, merging your changes into trunk if you're using Subversion, automating your build tests to ensure that any issues are found quickly. If you're making changes to your code and you're testing your code, you're able to find the problems in that application quicker. And this also doesn't mean that your code that you're continuously integrating has to be deployed. You're just merging branches. Whereas continuous delivery is you're actually producing valuable changes in your code in short cycles and typically deploying it, or almost always deploying it. This is also known as continuous deployment and continuous delivery. I usually interchange those terms. To do this, you really need automated build tests to ensure any issues are found that will prevent a deployment, would stop the process, and you wouldn't deploy bad code. You don't have to have tests. I mean, you could just run your application through this without tests, and you could deploy bad code. So testing isn't a big part of this. So which should you do? Should you do continuous integration or continuous delivery? Well, what I always tell people is what's right for your application. What is your application doing? In one of my previous jobs, I built a live component into an application that was a trading card platform. So there was this live event. Most of the application was just CRUD information, it was just CRUD operations, but there was this live component to where if we deployed right in the middle of one of these live events, we could potentially be changing business logic that would completely change that live event. So that's definitely a bad idea. So for that kind of project, we had to go towards a scheduled maintenance. So we couldn't do continuous delivery, but we could do continuous integration. And all that those two terms really come down to is you're branching off in your version control of your code, features, bug fixes, however you want to branch. This branching strategy doesn't really matter. It's just that you're continually pulling back into a centralized branch. So in my old job, the problem we had is when I got there was 2 developers, and they were scaling up. And it wasn't just one developer on one project anymore, which is how that company had been operating for years, and successfully. So they weren't really bought into version control. The core application was version controlled, but that was really the only version control they used. And the only time they really checked in commits was when they actually got it into a working state by copying and pasting and uploading changes to the remote server on the production system and deploying changes live. When they got something that worked and didn't throw any errors, they'd commit it. So version control is the obvious answer, and this is one of those things that some people take it for granted. Some people who aren't version controlling really don't understand the need. But hopefully this will show you and demonstrate what version control and the continuous integration process will be able to give you. So what happens if the team is just learning version control? And that's where we come to story time. In my old job, like I said, I was the 3rd developer hired. So we really didn't have version control in place. We had one core application that was a custom CMS, and we had hundreds of other smaller applications, which were essentially extensions of the CMS. It was a multi-site platform. And we didn't have any of that version control. So it was a nightmare trying to track changes. So what we ended up doing is going to Bitbucket and creating a ton of repos, and doing initial check-ins and creating a ton of repos. But the problem was, not that we weren't using version control, and we started using version control, and that night and day switch solved all of our problems. The problem meant that we had more developers contributing to the same code bases. We didn't have Jim and his project, or Sue and her project, or me and my project. It was, we're all touching everybody else's projects. We're in all of the code bases. So this was an issue for us. We had to figure out where our workflow was going to be. And kind of what the process we came up with was master was always deployable. That's what our philosophy was. You didn't break master intentionally. You would feature branch off of master, Feature branches would be merged into a dev or staging environment. The branch that would be pushed out to an environment. And then dev feature merged into master, and then we would do a release and a deployment. Well, what we needed, because this was a private application, closed source, that hundreds of clients were using and paying us to use, we had to have private build testing. We couldn't just stick this on Travis and call it a day. I wish it would have been that easy. It had to be cheaper free because I had to prove value to the managers. I mean, a small agency, we don't have the budget to just go crazy on an AWS account. We had to be able to prove value to the stakeholders and managers just outside of the fact that they already knew testing was good, they knew testing my builds was good, but I had to give them this solution and sell it to them. And we had to customize it for some pretty crazy things, or so we thought were pretty crazy things. We learned, and I learned later on, that what we were doing really wasn't that crazy. So what I found when I went out looking for a CI solution was there's a ton of them out there. There's Travis, which if you're doing open source work, you've probably touched Travis at some point. Travis is great, it's free for open source projects. Jenkins is another great, it's Java-based, similar to TeamCity, which is what we're going to be talking about. Java-based, multi-platform, super easy, super configurable. Atlassian's Bamboo product is really awesome. It uses your Amazon EC2 instances for build agents. So, and since it's made by Atlassian, you have all of the Atlassian accessibility and plugins and integrations built in. So Travis is great for open source because it's so easy to use, and they support open source by essentially being free. So the private projects required a paid account, and it's not hosted on our infrastructure. That wasn't that big of a deal for us because we were already paying Rackspace to host our infrastructure, so I wasn't really concerned about where it was going to live. But the private projects requiring a paid account, it's a great service. It's very much worth it. But when you're selling it to somebody who doesn't understand what you're trying to accomplish, it's a hard sell at $150 a month for one project. Knowing that this is an experimental thing, it's a hard sell. Some managers will go for it, some won't. So the next one I looked at was Jenkins. Jenkins was bring your own hardware, you can self-host it. I want to say there's a few software as a service companies out there that do Jenkins for you. It has great flexibility, great support. There's a big Jenkins community out there that's willing to help you or mock you for what you're trying to do with Jenkins, as I found out. So I don't know what it was. Maybe I just think differently about build testing and integrations than how Jenkins does things. It just didn't click for me. You try Jenkins, it's a great product. It may click for you, it just didn't click for me. So Bamboo, great Atlassian integrations, obviously. It's their product, it's going to integrate with Bitbucket, it's going to integrate with HipChat, all the cool stuff. It utilizes Amazon's EC2 stuff for build agents. So when you have an integration or a build test server like one of these products, you spin up a virtual machine, or it's just a hardware machine sitting out there that's going to run your code, run your tests, and give you the results. So for Bamboo, you just plug in your AWS credentials, and it just goes crazy, doing its thing on EC2. We weren't using EC2, we weren't using Amazon at all, because we were heavily involved in Rackspace. So we didn't go down this road just because we didn't want to have to go spend money on Amazon when we already knew we could either do it on our own hardware locally and not cost anything, or do it on Rackspace where we already were comfortable with the environment and knew how to do things there. So the greater appeal for this, I think, is definitely if you're already using Atlassian products, or if you're already using Amazon. This is an easy win. So where we landed was TeamCity. And what I really love about TeamCity is it's made by JetBrains, and I already love PHP Storm. So it's fully functional, free version. You're limited in the configuration that you can have. You can have 20 configs, built configs. And you can have 3 build agents max. Then as soon as you're past that, you have to start paying for it. And we'll cover what build agents are and talk about some of those limitations. And I ran my old company off of this, or my old job ran off of this. They still run off of this today. They still have not paid a dime for it. So, and they do probably 5 to 10 build tests a week. If you're doing more than that, you may want more. There are enterprise options. You can have unlimited configurations, more build agents. It's just how much money are you willing to put towards it? How much money should you be putting towards it, right? Maybe you are in a situation where you need to be doing 10 build tests a second, or 10 build tests simultaneously, sorry. It is self-hosted. You can bring your own hardware. It's super easy to configure. You can throw it up into Amazon, you can throw it up on a Rackspace. We threw it up on a Rackspace and ended up having some issues with it just because of some of the quirky things we had to do, so I ended up running it on a spare box in the closet. Not the greatest thing, but it works. It solves the problem. It runs on Windows, it runs on Linux, it runs on OS 10. It's Java, so it is Java. It's slow-ish, can be kind of heavy, but it runs everywhere. And that was really important to me because I was a Linux admin, but none of my coworkers were. So worst case scenario, if we had to shove it onto an OS 10 box in a laptop, they would be able to manage it. That was important for me. So what we're going to do is we're going to walk through the whole thing, and I'm going to show you a couple of build tests. And I've actually got 2 projects that I can show you, and we can run build tests on, we can break, we can do whatever. If anybody has any questions, or if it's something isn't clicking, please throw it out there. I'm not adverse to answering questions midstream. So if you want to install this, you're going to need Java. You're going to need a database to use, or if you're just testing and playing around, it's totally fine to use TeamCity's internal database. If you just want to poke at it, grab this Vega box. When I was starting this presentation, I was like, Google, Vega TeamCity, and this was the first thing, and I was surprised that it actually worked really well. This is a great Vega box. And this is actually what I did to build this entire slide deck. You'll create an admin account once you install, and you're ready to start building. So this is what you're going to see with a blank slate. You're ready to go. You're ready to start building. So we want to start creating a project. And you just need to tell it a name, tell it a project ID. For this first project, we're actually going to be using a project that a friend of mine wrote called Slim Off. His name is Jeremy Kendall. He's a big Slim PHP guy. He wrote this to kind of help with authentication for Slim PHP framework. If you're not familiar with Slim, it's a micro framework. So once you have your project set up, you create a VCS root, version control root. And this will work with GitLab, it'll work with GitHub, it'll work with Bitbucket. Anything that you can point at a URL, you're golden. You can use SSH keys, and I highly recommend it. I'm not doing that in this scenario because I didn't want to put my SSH keys in a Vega box. That is generally a bad idea. So once you have the VCS root configured, you'll do a build configuration. Let me step back 1 second. The checking interval down here is one of the advanced settings. If your application is just getting commits after commits, it's just getting hammered with commits, you may want to up this or lower it. This is how often it's going to check to see if there's any changes to pull down. There's another setting later called a timeout that will wait for X amount of minutes for no activity before it does a build. So you create a build configuration, and this is what happens every time a build happens. This is the container for the build config. And then you attach a version control root to a config. And then if your application or your project has a build.xml file in it, TeamCity will automatically parse that and try to guess how your project should be built. Jeremy's project did have one. It was completely off from what I needed to do, so I didn't use it. But if you're actually using that and you're doing some ant build stuff, it'll probably automatically work for you with TeamCity. So we had to manually add our build steps. And these are all the default build runner types that you have. And you can see TeamCity is definitely not targeted for PHP. It doesn't even support PHP out of the box. There is a plugin set that you can get that will give you PHP stuff, and essentially all it is you don't have to preface your command line stuff with PHP. It will just run them as PHP. The guy that wrote that, I can't remember his name, is really awesome. I wrote a blog post on how to do some of this build testing and trying to use containers and virtual machines, and he actually gave me some really good feedback on how I was doing this stuff. So the TeamCity community, if you ever have to go out looking for help, is very welcoming. So what we want to do, the first thing we do with this application's plugin is going to be a composer install. So we'll do a new command line build runner, and we'll just say composer install. And remember, since you're using this as Java, it's going to be a different user group. It's not going to be your user. Something you may want to do, and this is what I ended up doing for my old job, was I had our box, since it was our metal, it was behind our firewall. Nobody from the outside could get into it without getting through our firewall. I was a little lenient with my security. I had a build user, and I had them with passwordless sudo. They could do whatever they want. The only security I had on that box was you couldn't just use a password. You had to have an SSH key. And root on that box had to do that for you, or the user, somebody who had previous access had to do it. Somewhat secure. Please do your security better than me, so that's all I have to say there. But the reason I did that was because I wanted the actual TeamCity application to run as my build user. That way I didn't have to, and I forgot to turn off. I am on Do Not Disturb. I have Chrome open, I'm sorry about that. There we go. I was going to show you TeamCity later, so I have Chrome open. Didn't think about that. So, and what I wanted is I wanted the TeamCity to run as that user, so I wouldn't run into permissions hell. And we're going to kind of deal with a little bit of that permission hell here, just because we're doing it in that vagrant. Typically, unless you're doing something where you're moving files around, permissions aren't going to affect you. You shouldn't be anything too worried about. But just keep in mind you may need to do some less than awesome security things, so just be mindful when you're doing that if you're doing that out in the cloud. So our next step is going to run PHPUnit, because we've done Composer install, and we're going to run PHPUnit, and we're going to execute this step if all previous steps have finished successfully. And we're going to run our custom script, which is just part of the command line. We're going to run PHPUnit with no extra options. If you were using something like code coverage or something like that, you could run those options here. It'll generate those reports and send out those API calls if you want. So for this, we just have 2 build steps. We're going to run Composer. If that works, we're going to run PHPUnit. And the build, as it is now, if either one of those options fails, whole build fails. Whole thing just says, whoa, nope, stop. If Composer fails, for any reason, PHPUnit will never be run. So running our first build, you just hit the run button, and you have options. You can do a clean build. You can clean out all the files, and it'll force it to do a pull. Most of the stuff with Composer will cache a lot of that stuff. You can force Composer to clear out the cache, or checking this box to clean all files will pull that out, so it'll nuke the working folder. When you're actually running, you'll have a build log that you can click through and look at, and you can watch the commands being run. So we have right here, step 1, we're running Composer, and it's installing dependencies, including required dev, just regular Composer. You can get detailed output if you sit there and watch it. You can watch and see if there's errors. Each one of these steps, once it completes, it'll get auto-collapsed unless something went wrong. And this is the detailed output for our PHPUnit. We see all of our tests pass, the build finish, and we're successful. Typically, you'll get an email when this happens, and it'll say, hey, successful build, or you'll get an email when it fails. You can customize the notification preferences a little bit. If you want anything outside of email, you kind of have to do that yourself. You would either have to do a Slack API integration to do a call to send it out to Slack or HipChat. So what happens when you fail a build? Well, if we failed, it'll get this little nasty little error message and show you the exit code, which doesn't really do a lot for you. But when our build fails, the steps after will not run unless we tell them to. There is a way we can go in there and we can tell it to run those steps regardless. And there are some situations where you won't want that. So this is what you see when a build fails. It'll give you all this information on the time, the investigation. You can open an investigation if you want to be real formal with it. I never used this because we only cared about it passing and failing. We didn't care why, really. We always just poke fun of each other for breaking a build, and that was just kind of a culture thing. If you need to be super formal, investigations will be what you want to look into. So we see that our build failed here on PHPUnit. We ran PHPUnit. So we went and look at the detailed view, and we see configuration read from TeamCity agent, PHP failed error class, Zend authentication adapter, abstract adapter not found. Okay, so we're missing a class. That will definitely fail a test that we're looking for that's using that class. So we can find that break and change by looking at the revision under the changes tab of our build. And we can take this SHA hash, put it on GitHub, and it'll take us right to the commit where somebody took out that class, which in this case was intentional. It won't always be intentional. So when we revert that change, put our class back, run our build again, everything passes. All right, questions so far? Awesome.
Does this integrate with the HipChat or Slack or any of the team communication platforms?
It doesn't.
Okay.
But you can do custom commands, and you can do like a wget post or a curl post. I had a Laravel application being deployed using TeamCity, and I actually had, before Laravel Forge supported Slack and HipChat, I actually had a curl request posting to a Slack integration.
Okay.
It doesn't support it natively just because I think that's too modern. There is a plugin for Slack,
okay,
but I wasn't able to get it to use it when I tried. That's been about a year since I tried, so they may have fixed it by now. Any other questions? Excellent. So now for something a little more complex, something more than just a little two-step. And I don't mean to give Jeremy's application a hard time, but build testing, it really isn't that involved, right? You're doing two things. No big deal. So we're at a fork in the road here. Testing real things can be hard. Unit testing, you cover all your bases. Typically, you'll mock your dependencies and test in isolation, which is how you should be doing your unit tests. What if you want to test real things? What if you want to test elements on a page? What if you need to test that a database is actually being written to? What if you need to test that a JavaScript event is firing that hides or shows an element? These are the kind of things where really you should be putting them in Docker or Vagrant. And you should be testing against that Docker container or that Vagrant VM. I haven't done either one of those yet because I haven't had time to really get familiar with Docker. I've done some initial testing with Vagrant and having TeamCity testing against a Vagrant configuration. The problem I ran into is my build times tripled, waiting for Vagrant to come up and go down in provision. So that's why I still kind of cheat, and I'll show you kind of how we cheat and test against a local server. But in cheating, it does kind of take away from it. You're not testing against your actual environment, so you may really only want to start thinking about these tests as smoke tests. They may not actually be real isolated tests. If you need that real isolated test, you'll want to test against a Vagrant or a Docker container. So we're going to step through, create a new project. And this is an actual real application. It's the Hack Memphis website. It's for a hackathon event that we do in Memphis every year. It's a Laravel 5 app. There's not a whole lot to it, but we test real things. So we're going to create the project. We're going to create the build configuration. And then we're going to add a VCS root. And we're just going to point it towards the GitHub repo. And a quick note, if you're paying really close attention, we actually just did that backwards from how we did the first one. The first one, we actually created the VCS root before we created the build configuration. You can do it in either order. If you do it in this order, the way we just did it, where you add it after, you'll show you this little message and say, hey, attach. Doesn't matter how you do it or when you do it. So now that we're testing a real thing, we want to add our build steps, and the first thing still is going to be running composer install. And then we want to run our database migrations. And this is where we're kind of doing two things at once. Since we have this environment variable that we need for Vagrant, or for our Laravel application, to tell it what our database settings are, and then we want it to be in a specific environment, we want to tell TeamCity to copy over our environment example file into the .env where Laravel expects it to be. And that way we can kind of have a testing environment set up for our entire application, just like you would for production or local development. And then we'll do PHP Artisan Migrate, which is just run all of the Laravel migrations. Next thing we want to do, since we're testing real things, we want to see the database. And it just so happens with this database, or this application, I actually have all of the data in the database set up statically in my database seeds. That way I can just nuke the site and always pull in from my database seeds and have the site back up and running. There's not any interactive component to it. The next thing we want to do is we want to run FanJams. And the reason we need FanJams is because we're going to run Inception, which is going to do some acceptance testing for us. And the problem is, if you just run FanJS, it takes over your console, and this becomes a process and it just runs forever. So we cheat, I'm really good at cheating. And we throw it in screen. So we do screen dash capital S server dash D dash M. What that does is it tells screen to start up a new screen window called server, detach, but run this command. So what it will do is it will run the FanJams and detach, and this process will terminate and continue on to the next successful task, or the next task in the build order. So then this is where we get kind of dirty. I'm going to copy all of these files that we just pulled down into a Vhouse that I have locally on the machine. I have PHP 5.6 on this machine. I have Nginx. It's really close to my production environment. So I'm relatively comfortable with the setup. And this is where we ran into some permissions, so I had to sudo this stuff. And then I had to chon it back to www-data, which was my Nginx user. So the next step, we run codeception. Vendor bin codecept run. And we want to make sure that all of these steps so far are only going to run if we've previously been successful. That way, at any point, the build fails or a step fails, we'll stop, because we don't care. So the next thing we want to do is, once codeception's run, we want to stop FanJams. This is the only application on our build server using FanJams. We don't need it running 24/7. So this is the first situation where we do want to change this. We always want to execute this step, even if the build stop command was issued, even if some of the previous steps failed. So we always want to run this if previous steps failed. Also, since we're using a real database, the PHP Artisan Migrate was running on a real database on this system, we want to clean up that database. So we do a custom script that just runs MySQL from the command line, drop database, create database, grant all privileges. Drops the database, recreates it, and then it resets our permissions for our user. Again, this is a prime example. My build server is super insecure, because guess what my root password is for MySQL? It's Vega. In this scenario, it's a Vega, and I don't really care. It's a disposable machine. In your environment, if you're doing this out in the cloud, please use a real password. So now we're ready to test our build. We run all of our tests. We composer install. We move our environment variable over. We run our database migrations. We run our database seeder. We start up FanJams, copy files over. We run codeception. We stop FanJams, and we clean up our database. And if we want to go verify our tests, we can go through and look and see that, hey, all our tests passed. Good news. Now to automate our builds, because we don't want to just sit here and run these builds whenever we feel like it, because that's a pain. We want them to run every time somebody checks and changes. And this is where I was saying earlier, quiet period mode is where you're going to want to tweak this, probably depending on how often you're pushing changes to your branches, and also what branches you're changing, or you're build testing. In this example, we're only build testing master, because that's really all I care about for these two projects. I don't actually have those development branches. So the quiet period mode, you can set it to just not use it to where it will always test everything. That gets really loud if you're checking in really quickly. Or you can set a custom. And what this means is it'll wait this timeout period after somebody's done the last check-in. So if you have 5 commits, you push that, you make another commit, you push that again. If that's less than 60 seconds, this won't trigger 2 builds. It will only trigger 1. It'll wait that timeout. So the other triggers you can do is you can schedule a trigger. You can do it on a specific time and day. You can trigger something on a build to happen. You can trigger a branch remote, something happening to a remote branch. If you're doing some elaborate multi-branch setup, you could have something trigger where when dev gets updated, you check master or check another branch. You could do a retry build trigger, and that's somewhat helpful if a build fails and you think you have this just intermittent issues. You could just force a retry of a build. So now we have automatic version control triggered build tests. So what's the next thing we do? Well, once you know everything's good, let's deploy. Let's set it free. So the deployments can be a build step away because you're doing essentially command line operations here in your build steps. Or if you're using .NET or Java or something else, you can actually do much better integrations with your build steps. So for the Hack Memphis application, I'm actually using Laravel's Envoy to do deployments, which is just essentially I have my SSH key set up between my machine and the production server, and I have this envoy command specified to do envoy run deploy prod, and that runs my deploy script on the production server. So this is what a deployment would look like. And when we run that command locally, it actually connects out to the remote machine and runs the deploy script on that server. And our deploy script is essentially artisan down, which puts the site in maintenance mode, nukes the database, reseeds, runs the migrations, just like our build step. Seeds the database, pulls pulls the migrations. It pulls the application out of maintenance mode, and then we're back up and running. So anything that you can script, any shell script you have, can be a part of your build. And like I said, if you're using plugins or if you're using some other supported thing for TeamCity, that can be part of your build as well. So some of the pain points that I had in doing all this, and it's, it sounds easy, it looks easy, it can be a pain. Part of the issues that I had is duplicating your production environment within TeamCity or within some other CI service. With the older version of CentOS as my production environment running PHP 5.2, I had some problems at my old job getting that CNS application to run in TeamCity because I wasn't able to, I didn't want to run my build server on CentOS 5. So I actually think I tried that once, it didn't work because of the Java version issues. So there was a lot of trial and error I had. And I ultimately settled on getting as close to production as I can. And just remember, as close to production as you can get is only going to be so good, depending on how you write your tests and depending on what you're testing. So starting out, there's going to be a lot of trial and error. There's going to be a lot of failed builds. And don't feel bad about that. I think one of my first applications had 60-something failed builds before I got my first successful build. And then I immediately had another 40 after that were failed. There's a joke out there about the first git commit of your project is always an initial commit, your next 5 or 20, or getting your CI service running, or Travis or TeamCity or something. So don't forget to back up your CI server settings. This is the thing that bit me a couple times, even in writing this application, or writing this slide deck, because I was doing all this in Vagrant. I would break something, get mad, and Vagrant destroy, and then there was my TeamCity configuration. That was a little bit of pain. But despite the pain, the payoff is better than the pain. You're going to get quick feedbacks on your commits. Your developers are going to get feedback faster without waiting for something to go into production. The confidence level of your merging is going to be huge. You're not going to be worried about, well, what about this conflict? What about that conflict? You're going to be testing all of this stuff. You're going to have less time resolving your conflicts because you're testing your code and you're merging often. There's going to be less chance of a conflict. You're going to automate your deployments and you're going to have advanced build notifications. When Codeception, if you've never used it, when something goes wrong, you get a screenshot and the HTML output of the failed test. So you can go and look at that in the work folders of TeamCity and see what exactly went wrong. You should see that locally. In some instances, because the development environment and the TeamCity environment aren't exactly one-to-one matched up, there could be some differences there. So before I finish, I want to actually show off this. We'll do the Fireflies
The
this
background is beautiful.
Thank you. I had to make sure I didn't have any crazy backgrounds going. Okay, so I showed you that TeamCity Box. It is on github.com. Actually, I have it right here. So this TeamCity Box is super small. It's like 5 files. The guy that wrote it did a really good job, and he actually updated it. He wrote this back for TeamCity 7, and then he went back 2 weeks ago and updated it for TeamCity 9. 9 is the newest version of TeamCity. These are some custom hacks I've added to it. So if you go pull down his repo, it's not going to be exactly what I have. I did this because a lot of the stuff that I'm doing here is what I needed to run my application against a local version of Nginx. Because his just had TeamCity, running just a PHPUnit test is fine, but I needed Composer, I needed PHP, I needed Nginx. I wanted to ensure my database for my testing environment existed. I wanted to set up MySQL and do some of those other things. I had to create my Vhouse. So there's some overrides there. If you look at my fork of this, all of these changes are there. My GitHub is Supernova SV, Supernova 09. This is a fork of his repo. It's all there. I'm not going to pull request this in because this is probably a lot more than he bargained for. But the rest of the script is what he wrote. And it's really easy. It's just a wget, and then you run some of the scripts to install TeamCity, and it automates all the Java stuff, so you don't have to worry about accepting the Java end user license agreement. And then when you're in the, since it's running in the VM, it maps port 8080 from localhost. The live demo got, or not smiling on me. Is anybody not familiar with Vega? Does everybody know what Vega is?
I haven't really used it until this conference.
Yeah, Vega is great for being able to spin up and destroy virtual machines really fast. Probably just super unhappy. This command right there is what makes Vega worth every penny and all the time that you start off with. Since you're using a box file that is essentially a snapshot of your VM, you can destroy it and recreate it. Now I'm just really hoping that I have my TeamCity backup recent. I won't spend a ton of time on this. All the stuff that's scrolling through there is that script. It's just installing Java, it's installing all the PHP stuff that I needed. This should take just another couple seconds. so that's where it's actually downloading TeamCity. Oh, that was PHP. That's TeamCity. Oh, that's saying it's going to be like 7 minutes. Okay, I'm not going to worry about that. If you want to catch me later, I can show you that. But please leave me some feedback on joined in. If you have any questions, I'm more than happy to answer some questions on TeamCity or Vega or anything. No questions?
Why did you choose TeamCity over Jenkins?
Jenkins, I couldn't wrap my head around. I couldn't make it. It didn't click with me. It just didn't. I tried to get everything working, and it just kept. I felt like I was fighting with it more than I was actually doing anything productive with it. Could have just been me. Could have just been how I was trying to solve the problem. It's a perfectly acceptable solution. I know a lot of friends that use it, and they seem perfectly happy with it. TeamCity just clicked with me. Maybe it's because I'm just really partial to JetBrains.
So is TeamCity's, all of these are proprietary software, right? Or is Jenkins, open source? I can't remember.
I actually don't remember. I know TeamCity is not open source. I don't know if Travis is. And I'm fairly certain Bamboo is not open source either. Could be wrong. I don't know. I guess when I was out looking for stuff, I didn't really find anything in the open source world that seemed like it would be not really robust enough, but stable enough.
Yeah, like fully baked.
Yeah. There's PHP Sky is a thing. That looks really good, but it didn't. I guess when I tried it, I had a hard time getting it to be stable with the code I was testing on it. So I don't know. Your mileage may vary, I guess.
So what about like reverse? Let's say for some reason you deploy something and you find out 2 hours later, hey, it has to go back.
Well, if you're doing continuous integration, technically you shouldn't have deployed anything that you knew was going to be broken. If you found something like an edge case where your test just didn't cover that, you would need to just run through this whole process again. You would need to fix the bug, push it to your branches, and then CI would take over. If you have deployment set up, deployment would deploy the fix.
Okay, so you would just go back to the previous version and
Right.
deploy that.
There's been a couple situations where business needs did not allow that, where I really had to SSH in and fix a bug right then. I've had to do that a couple times. It's just a matter of backporting your fix back to your changes and letting your CI run.
So in your CI environment, did you have developers? I guess you had 2 people there, but did you have developers on the production systems? Or?
Well, when I got there was 2 people already, and they were doing FTP uploads to production, and that was the workflow. And I was the 3rd person doing that. We did that for a while until I was just I got tired of stomping all over the other developers' code. So I was like, screw it, we can do this. So we really kind of disabled that. We took away all of that, and that kind of upset people, and it was just more of a training thing. But
so when you did your continuous integration, you basically said, okay, we have this person whose job is to maintain the
right. So our CMS platform at my old job, that was the big paying the bills app.
Mm-hmm.
That one was what I became the deployment manager on that one. We didn't have CI deploy that because of how many sites could be affected by any small change. So I took on the role of, I was the deployment person for that. So what would happen is we'd push changes would pass, CI would say, hey, everything's fine. And we even had an integration set up with HipChat and Slack and stuff that would warn us and say, hey, this failed, this was successful, and that's when I would go do a deployment manually. Because we actually had to disable FTP access just to keep stubborn developers from doing stuff the old way.
Did you have a lot of pushback from that, or?
Initially at first, because it was one of those situations where we had one person that just wasn't really wanting to learn how to touch something. I learned how to do, somebody just didn't want to learn how to do things, they just weren't into it. But they were quickly persuaded once they saw how we were doing stuff.
So if you're a continuous integration environment, you recommend not allowing developers, because one of my problems is I'm on a team of 4 people, and there's about 2 or 3 of us that have been kind of just doing deploys, and I've been taking over the deployment management. And I'm getting to the point where I'm like, okay, I wanna just kind of isolate that environment, because when you have, it seems like when you have like more than one person in it, it's kind of too many cooks in the kitchen.
Absolutely. And the easy thing there is what I would probably do is just take deployment away from your CI, or not even put that in. And then it's just a managed CI. And then if you have to, just revoke people's access to the deployment. I mean, it's a not so subtle way to possibly upset some people, but if management is behind you on it, I mean, I've always been in really small places and really small teams, so it was never that big of a deal for me to say, hey, I'm going to own this little piece of the business. So. Any other questions?
I noticed you're pulling PHPUnit down from the FAR.
Yes.
Is there a business need that has you doing that instead of pulling it in with Composer? Or is it just like...
Pure laziness.
Sorry?
Pure laziness.
Excellent.
And more of my most recent, at my old job, we actually had, the CMS platform was on such an old version of PHP, I had to pull down the FAR. So that was always I couldn't use Composer because I was on PHP 5.2. I could use it in development, and we actually did, and that was horrible. But yeah, so downloading the FAR from the site is just like that's my go-to reflex.
Okay.
Some of my more recent stuff doesn't do it. And typically, some of the stuff that I'm doing, or most of the stuff I'm testing now, doesn't even use PHPUnit directly. PHPUnit is a byproduct of Codeception. So, all right, thanks.